Speaking of reliability, a podcast with good friends talking with you about reliability engineering topics. Welcome to Speaking of Reliability. This is Fred Schenkelberg.
And this is Greg Hutchins. Good morning, Fred. How are you?
Hey, pretty good, Greg. Good talking to you again. Hey, we've talked, I don't know how many times, a good number of times, and I don't think there's a single episode that you haven't mentioned risk or risk management, which is natural. You spend a lot of your time in that world and doing various aspects of it and writing about it and so on. But one of the things I dawned on me, and it was based on a question I got this morning, is, well, how do you, once you start identifying the risks to a project or to a program or a design or something like that, and you start thinking through all the ways something could fail, for example, it gets pretty overwhelming real quick. And so it dawned on me is, how do you, once you recognize that you're dealing with risks, what do you do? How do you deal with that?
So in other words, where do you start?
Yep.
Well, for me, if you go into any one of the standards, let's take ISO. They've got 40 definitions of risk.
40.
40. Yeah. Anything from not being able to meet your requirement to, the chance of likelihood times consequence.
Mm-hmm.
There are a lot of definitions of risk. And if you're just simply starting, probably a lot of us are working a project. It could be a big project, it could be a small one. And one easy way to look at risk is you've got a target, any variation away from that target. And I'm trying to think in terms of quality or reliability. If you got a target, it could be a target on a machine, 1 inch that you're trying to target, and then you've got a upper and lower spec limits, and then you've got upper and lower control limits. Mm-hmm. Any variation away from that target is a risk. And the question is, what is your acceptable level of risk tolerance, risk appetite? If you're working on a project, think about the 4 constraints in a project: quality, scope, budget, and schedule. Each one of those has a target. You've got a target for your budget. You've got a target for your schedule. Any variation away from that target is going to be a risk.
Well, wait a second. Any variation, and I agree with you, but I think most people assume that if you're late with the project, that's an adverse outcome. And it means cost overruns. It means not shipping on time, and all these other horrible, bad things happen. But mm-hmm. You're saying, though, if I'm 2 weeks early, I'm okay? That's a risk, too?
If you're 2 weeks early and you're looking for a shipment of products and that product shipment comes in early, what happens? It goes into inventory. Inventory is a cost. That's a risk. You have to keep that inventory around,
Mm-hmm. Mm-hmm.
So depending upon how you contextualize that, if a shipment's late, obviously your factory floor, if you're doing just in time, is going to stop. If you're too early, you're going to have buffer inventory. That's a cost factor.
Got to have some place to store it, and store it such that it doesn't deteriorate or degrade or get damaged.
Absolutely. If you're running a project and you got a critical path and one part of the project is 2 weeks early, you're going to have people sitting around not doing anything because a critical path basically says that all these milestones have to be done in time, or at least closely in time. And if there's too much variability, that's a risk. Meaning, in case of a project, that's going to be an additional cost.
Mm-hmm, mm-hmm.
So if you're just simply starting your risk journey, think of your targets and any variation around those targets. It could be a process target, a product target. It could be even a project. And think in terms of what are the risks if there's too much variation. That's one way to start.
Right. And the example of, here's the date we want to start production. Mm-hmm. Varying that one way or the other, both have problems and increase the cost. But it's like the tolerancing part, though. It's the idea is that it reminds me of the study that was done years and years ago, I think in the 80s or maybe in the 70s, of why a transmission, I think it was a transmission or a motor, an engine, an automobile components, the same design had such different outcomes when one was made in Japan for one model of car, and the very exact same set of blueprints, essentially, and process was used in Detroit for another style of car, or another very similar car. And the U.S. made ones had a horrible track record in the field, where the ones in Japan ran very well for a very long time. And so the idea was, I think the end of the study was basically saying the folks in Japan strove to get to the nominal design, the ideal design, the center point of whatever it was for the various specifications. And we're continuously improving to get to that. Whereas the Detroit teams were, hey, it's inspect, ship it, and didn't focus on getting better than just inspect. And they thought, well, that's the specification. That should be good enough. And it was an illuminating comparison of the difference in the philosophy or approach. And illustrating, I think it's called Taguchi, loss function.
Right? It is Taguchi, yeah.
But
what?
Yeah,
yeah,
go ahead.
One of the hardest things, and you're talking about a product production example, so let's sort of run with that for a second. Not only were the Japanese looking at the right attributes, product attributes, or product characteristics, but they were basically controlling those, minimizing the variation at the target, at the nominal, and coming up with control limits that were obviously quite often tighter. But there's really another risk picture that I think we forget about when we're designing a product or software. And that's, what are the critical attributes, the critical characteristics, the critical factors that we want to look at? Not only is it important to, have the control checks and do the Six Sigma analysis, but the larger issue is, what are the critical few attributes compared to the insignificant many that we want to look at? And that goes back to our assumption study. Do we really know what the customer wants, the voice of the customer? Do we, in terms of a product, do we really know what will keep a transmission running 100,000 miles compared to 50, 60,000 miles?
Right.
I mean, it's great to have the tools to control the variability, but we need to look at what are the critical factors.
This sounds like, I have never seen it actually used. It's the house of quality, where you're connecting, what's important to the customers to all the way to your control factors on the production line.
Yep, that's exactly right. It's the house of quality.
Yeah, but the idea is that I don't want to restart our discussion on assumptions, because that will just that'll go another 20 minutes easy. But and that's in our last episode. But the notion is that I think you're right. And I've often seen it in plans and in some organizations where it's critical to quality. There's might be 40 different call outs on a design for for dimensions, but not all of them are critical. So at some point, the design team says, no, these 4 are the ones you really have to pay attention to. The rest of them, you still need to, meet the requirements. But these are the ones that have the highest risk, of the highest potential for variability. And it might be due to material properties, it might be due to wear of the tooling, it might be whatever. But thinking through, what's likely to cause the most havoc if we don't get it right, and as right as possible. And so I've seen it used that way, as critical to quality, where usually it's a risk assessment in some type of form or fashion. It could be an FMEA, it could be design analysis. But it's a way to say these ones are the most important. These are the critical ones. And that's one approach, is just sit back and go, what's the most important ones and most damaging if they're not done well, kind of thing. But that's just the start. You start identifying it, and I've seen some people will list, well, they're all critical. Well, that makes none of them critical. Come on, give me a break here.
And that's basically a reflection of the maturity of thinking and maturity of decision making, because some, they're not all made equal. Meaning, that little process you mentioned, critical to quality, is really a risk type of process.
Yep.
And that's one reason why I guess I've been banging one drum for a lot of years. The future of quality is going to be risk, because when we're doing an FMEA or a critical to quality analysis or even an SPC, that's really a variation decision-making or risk decision-making example. And I think that's one reason why we have these podcasts is a lot of the quality, reliability, thinking and doing and decision-making is really risk-based at the end of the day.
Well, it's not that it's the future of quality. I think it's what we've been doing all along. Right?
Absolutely.
Right?
Absolutely, Fred.
But I think it's the reframing that. So if you're kind of going, well, what is this risk management stuff? Well, the good news is that we've been making decisions and addressing the impact of variability on things, if you're making good decisions, in my opinion, which is all part of it. But so part of it is to start is, well, what's the target? And there are some projects that apparently don't have a particular target or specification. They're not well defined. Let's go make something. Well, what? And, well, we got some sticks and some glue. Let's make something. And it's not very helpful, guys. But starting with, well, what's the objective? And then that it doesn't take long. Well, what's going to cause this not to turn out right? And it could be a supply chain problem, or it could be material properties change, or it could be whatever. But just get a quick sense of what are those major players, and then start challenging those assumptions. Just start going down that line of thinking, and more critical ones, you do some what if analysis, or you do some the design of experiments, or you characterize the impacts of the amount of expected variability, whether it's stresses or material properties or whatever. But it's it's like, I look at it as FMEA, is you stand back and you say, all right, what if we don't, what could cause this thing to fail? What are the issues? And then let's prioritize them. It's a way to get at it. Hazard analysis, design reviews, all of those things are ways to expose the impacts of variability on whatever that system or project you're working on. That's just the start, right? Because now you got to do something about it. Right? Writing the FMEA is not the objective, kind of thing.
And basically, you said it really well. The impacts of variability is really risk-based thinking.
Okay.
And, you basically, I would add one more thing to your analysis. What's the problem you're trying to solve? Yep. If you define that early on, then everything else will fall into place. And that thinking, that process you described really so well, is really a risk-based problem-solving process.
All right. So now let's say we've identified what we think are the critical factors or the significant risks to our project. All right. And I know from one of your books, I know there's at least 4 methods, and one of them is ignore it, which is my favorite method. No, just kidding. But some risks are, you can monitor it, see if it occurs or not, and have a plan to recover or respond to it if the risk does come true. If that amount of variability, that unwanted variability occurs, what can you do about it? Have a backup plan B kind of thing. You can mitigate it, right? Do something different in your design. Change the concept so that critical factor is designed out of the product, or it has easier tolerances to actually construct or build or maintain, or whatever. It just soften it is one way to think of it. Now I'm drawing a blank on what the other two are.
Well done, Fred. Okay. The easiest way to sort of manage your risk is just simply reduce the risk by looking at it in terms of two components: reducing the likelihood, reducing the consequence. This other decision point is avoiding the risk. Just simply say, I don't want to design this product. I don't want to use this supplier, replace that particular part with another one. Another decision point is just simply transferring the risk. You can basically do that by getting insurance, finding another supplier, meaning a prime supplier as well as an acceptable alternate. And then probably another way is to is to simply accept the risk, right? It's within our risk appetite. It's not a critical product. Let's use that supplier. There are lots of ways anyway to manage risk. A real fundamental, though, is to take those four elements: sharing, controlling, transferring, and basically incorporate that into your decision making. Because at the end of the day, risk management is really minimizing the variation of the risk one way or another. And there are really four methods to do that. And I think that should be part of all of our portfolios for being a quality professional or being a reliability professional.
What I've seen so many times, though, is that we'll say, all right, well, yeah, we've got some problems with that variability on this component. We saw a handful of our prototypes fail, and I says, yeah, a handful, like 3 of the 10 that you made, don't work because of that variability. And when we scale this up, that's 30% of our products are not going to work. And we'll make it up with warranty. We'll plus up the warranty bill, or budget. And I'm like, well, that's transferring it to the guy that's running the warranty program.
Yep.
But in my mind, it's not a really mitigating or reducing that risk at all. But there's a choice, though, right? Is some things we just can't change. The weather, the stress caused by weather on a product that's a portable device or an outdoor device, the weather's going to be what it is. We can't just ignore it or say, "Oh, we put it on the data sheet that you can only use it at 20C." Well, that you can't assume away the variability.
Yes, and this basically is a follow-up to our discussion about writing down assumptions.
Yep.
We're treating much of this discussion as, in terms of risk and variability, as point failures. But the reality is most risk tends to be sort of jumbled up with a bunch of other factors. We've got cascading risk. Anyway, we have risks that come from 2 different sources. We have all types of stuff. And one of the really critical items, from my point of view, and that goes back to our previous discussion, is writing down the assumptions when you're doing the problem solving, the decision making, or you're doing the testing, because so many of the risks tend to be intervolved or interweaved, or they come together in strange ways. And the more we have this stuff written down, the better we can understand what's happening.
Yeah, we might have to come back to that assumptions discussion a few more times, because I think there's a lot more in that. But you're right. It's the part that I see as the cascading part is that it's not just the risk to this particular project. Say we're designing a product and getting it out to the market, and we have a schedule and a budget and all those factors that go into managing a project, and those are all great. But the better projects also keep in mind, well, what's important to the customer? What's the risk to them if our product doesn't work? So if it's a server that's running your banking system or your inventory management for your sales and warehousing, it could put you out of business for however long that's not working. So it can have dramatic range of failures. For us, it might be just a warranty replacement. Well, okay, here's $1,000. That's not a big deal to us. Yet that $1,000 piece of equipment could shut down your operation in your factory, and if it fails and it's managing your workflow. So it's that part I don't see many projects write down or specify. Well, what's the impact of these risks to the customer? And I think that's another dimension for a way to think through this, is not just what's the risk to me or to my organization or to my supply chain. What are the risks on the end of the process to the customer?
Yes. So what we do, and we simplify this whole process that you're describing, is we look at risk in terms of the enterprise level.
And that's conveniently called enterprise risk management.
Yes, 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 with the great acronym ERM.
Yeah.
But you basically look at risk from the high level down to the business unit, programmatic, project process, product, and transactional level. And interestingly, when you do that type of analysis and you look at the root causes, or even the what we would call the the first tier causes, when you look at that whole structure, then you understand what are the risks to the system and to the customer.
Yep. Well, there's a lot more here. So I think we just scratch the surface and say, I think the bottom line is most of us already do a lot of these activities, what we would call risk-based decision making, and have a way to approach these things. It's a little bit different language for most of us. The risk appetite, for example, that might be a whole podcast by itself. But the idea is that it's stepping back and like a design review and saying, did we get this right? Did we challenge? Did we think it through? And that's the heart of it, in my mind, is that, do we want to ship this product? What could go wrong?
Absolutely. Absolutely.
Oh, okay. I'm trying to think of where that article is. Because I know I wrote an article that talked about reduce, transfer, that one. I'll have to see if I can find that, add it to the list. And anyway, so if you're listening to this, and what in the world are you guys talking about, or if it's not clear, let us know. Head over to accendoreliability.com/go/SOR, and you can find a couple of ways to get in touch with us. And Greg and I and the other hosts of the show are available through LinkedIn and through our About pages on Accendo. So there's plenty of ways for you to get in touch and let us know. One, appreciate you listening. And two, if you got something on your mind for this topic or one of any of the other topics that we commonly talk about, we'd love to hear from you, because oftentimes we can provide some kind of guidance or answer or direction, but we also then likely expand it out into a whole podcast, and it makes for good discussions. That's the best part about it. So with that, Greg, hopefully you have a risk-free day, but I don't think that's possible. But hopefully minimal risks for you for the rest of the day. And we'll chat again soon, I'm sure.
Absolutely, Fred. And by the way, if any of your listeners want a webinar on any of these topics, just give us a holler.
Perfect. All right. Thanks, Greg. I'll talk to you soon.
Bye-bye, Fred. Bye-bye.
Thanks for listening to Speaking of Reliability. We invite you to join the conversation. If you have a question or a topic that you think we should discuss in a future show, please let us know. You can find a comment box below the episode show notes, or just leave a note as part of a review on iTunes.